Well, hello everyone. Thanks for joining us to GOODWE PV Building Materials sharing webinar. I'm Victoria, the Product Solution Management Engineer from GOODWE, and I'm very excited to spend next hour with you. So this webinar is held by GOODWE PV Building Materials BU and TUV Nord. GOODWE PV Building Materials BU is dedicated to providing customers with integrated PV building solutions based on the comprehensive use of renewable energy through PV building materials and their applications. And as we all know, TUV is global leading testing and certification laboratory. So it is worth mentioning that GOODWE PV Building Material has obtained the first IEC 63092 certificates from TUV Nord. And in this webinar, we would like to share the concept and application of PV building materials, and also the integrated solutions provided by GOODWE, and also is a vital part of Eco-Smart Home solution, which is composed of PV building materials, ESS, EV chargers, and SEMS. So this webinar is divided into 3 sections. First of all, we will share the application of PV building materials on pitch roof by Rita from GOODWE PV Building Materials BU. And then there will be an interpretation of PV building materials product test standards 63092 by Kira from TUV Nord. At the end, we will have 15 minutes of Q&A time. So if you have any questions through the webinar, please use the Q&A button. Please don't use the chat box, because as conversations go on, we can sometimes miss the question. So we can answer the questions in the Q&A session, or we can just answer them after this event offline. And also there will be a lucky draw section at the end of webinar. We will draw 5 audience from the background. The prize is Amazon gift card of $20, and the winners will receive a notification email from the community. And now I'll hand it over to our first speaker, Rita, the Senior Product Solution Engineer from GOODWE, to share the application of PV building materials on pitch roof. Welcome, Rita.
Thank you, Vicky. Hello, everyone. I'm Rita. Welcome to our webinar. The topic of my today is the application of PV building materials on pitched roofs. As you can see, there are 2 keywords, the PV building material and the pitched roof. Perhaps many people are not sure what is PV building materials. I think you will get the answer in the next 20 minutes. Here are 3 points I hope you will catch from my presentation. What are the PV building materials, and why we focus on the pitched roofs, and also how to apply PV building materials on pitched roof. So my slides are divided into 4 parts. Firstly, I will introduce the GOODWE Fosun smart solution called the Eco-Smart Home, and then I will address 3 issues in turn. About Eco-Smart Home, some of you may have heard about the solution we have launched at in the solar show at the European Fair in Munich, Germany in May. This solution is composed of PVVM, invert, storage battery, monitoring, and management system. They can work together to meet your home's unique power needs in an eco-friendly and sustainable way. This diagram here clearly shows how they work together to form a complete system. The electricity is first generated by the photovoltaic building materials on the roof, then converted to AC by the GOODWE invert, and then transmitted to the storage battery and home load, at which time you can see the power generation and the other data through the management system. And even the excess power can be sold to the grid through the monitoring statistics and bring the economy benefits. A very important role in the system is played by PV building materials, as it provides the most basics, which is the generation of electricity energy. If you are new to PV building materials, perhaps you will be familiar with the explanation, the BIPV. The full name is Building Integrated Photovoltaics. It used the PV materials to replace the conventional building materials in part of the building envelope. such as the roof, sun slide, or facades. And the product specially designed to be integrated into a building envelope became commercially available in the 1990s. Buildings, especially patched roofs, have been found to be great value of photovoltaic power generation. Both the roof and the PV modules need to be tilted. And the combination of the two has led to the original form of BIPV. But what happens when PV modules are applied directly to a building? Firstly, the unreliable of the mounts will cause the safety hazards. Besides, the modules not fit in with the style of the building, and the supports are not durable, etc. So definitely, it's not a good choice to install the general PV modules on the roof. How can a traditional roof tile protect a building better if the PV modules is removed? As a building envelope, safety is the first consideration. It needs to be fire, water, and wind resistant. And ideally, it should be easy to clean, long life cycle, and be easy to install and maintain. So even as a tile lying quiet on the roof, it needs to meet these requirements. But why do we have so many requirements for tiles? That's because the people spend 19% of their lives with buildings. Therefore, a good building environment is very important. So is there a product that can generate electricity and at the same time performance excellent as a building material? Yes, the answer is the PV building materials. This is why we are redefining the products of BIPV. A good product must first of all have excellent performance in the building envelope, but also have the ability to generate electricity efficiently. It means the three requirements of safety, aesthetics, and productivity at the same time. So that is a PV building material. And also can be named the PVBM. But now you would have understood the meaning of PV building materials. We will cover the second question, why we focus on the pitched roofs. By definition, a roof with a slope of 20 degrees and above is known as a pitched roof. It is used in a wide range of architectural styles and is the most common form of roofing in our daily lives. This is due to the following advantages, such as the good drainage, greater resistance to wind, and the other challenges posed by the weather. So maintenance can be reduced. In addition to another reason more close to today's topic, it facilitates the installation of photovoltaic systems. Now, let's have a look at the construction of a typical pitched roof. Starting with the roof deck. And a layer of waterproofing membranes is then laid on top of the structure, which is the first waterproofing layer. On top of this layer, the counter batten can be installed. This is so that if any rainwater enters the roof structure, it can drain out of the system along the batten. The next step is to lay the isolation layer on top of the previous structure. Following this, a layer of aluminum foil waterproofing membranes is laid, a material that is not only waterproof, but also can reflect the radiation, so that achieving an isolating effect. After this, you can install the tile batten, which is used to install the tiles. Next, the main tiles can be installed, as well as the other accessories. This completes to the whole roof structure. And this is a common practice for the normal roofing. As you can see in this slide of how the roof looks with the GOODWE PV building materials installed, it's very similar to a common roof. This product is the sunshine tile because it can be matched to the conventional tiles. This also means that you don't need to make a new roof to fit a PV system. What I'm going to show is standard roof construction with sunshine tile. It's not much different from a classic roof, but with the photovoltaic tiles where you want to generate power and a more secured roof. Now that we have discussed the PV building materials and pitch the roofs, let's consider the last question. How can we combine the two? To solve this problem, we first need to know the detail of the sunshine tile. The standard version is 1,508 millimeters long and 420 millimeters wide. Notably, the same wide as the conventional tiles, which is key to ability to be mixed with the traditional tiles. The length and width of the exposed sunshine tile after installation on the roof are 1,568 and 370 millimeters respectively. On average, each 1.58 sunshine tiles can reach the 1 square meter. The standard power rate is 92 watts per tile and 170 watts per square of it after installation. The weight of each tile is 11 kilogram and the finished installation weight an average of 18 kilogram per square meter. It can be installed in a range of 17.5 to 75 degrees, which will fit most of the roof slope. Another unique design point of sunshine tile is the file mode design, which means that you can complete the installation by removing the file tiles you currently have on your roof and replacing them with GOODWE tiles. And conversely, if you remove a sunshine tile, you can fill the gap with the 5 regular tiles. Furthermore, cement tiles weigh between 48 to 50 kilogram per square meter. Even square meter tile is 48 kilogram per square meter. But for sunshine tile, just 80 kilometer per square meter. This is a particularly great relief for the roof structure, especially in the event of the earthquakes, where a lighter roof would be safer. Next, I will show you how to install it onto your roof. It's very simple. Firstly, make sure your roof has the tile button that match the installation requirement. Then attach the hooks to the tile button with screws, and you are ready to install the tiles. Install them from the bottom to the up until you have completed the whole roof. The quality of GOODWE products is very strict as a company with the power electronics technology at this core. We have obtained TÜV Nord test certification for IEC EN 61215, ENIC 61730, and IEC 63092. Today, we also have invited experts from TÜV to expand the relevant test stand after my presentation. Perhaps by now, you know more about the PV building materials, which form an important part of the GOODWE eco-smart home. But of course, this is an integrated solution, also includes the company's other products, such as inverse, EV charge, etc. Together, we are a smart, eco-friendly, and sustainable way for living. I would like to show you 3 projects that we have been built using the sunshine tiles. The first is the kindergarten project in Guangde, Anhui Province, China. The roof of this building is completely covered with the sunshine tiles, which generate 121 megawatts of electricity per year, which is equivalent to a reduction of 96 tons of carbon dioxide emissions, or the planting of the 5,310 trees. The second is a hotel project in Shanghai. which generate a 102.1 megawatts of electricity per year. Element 2, a reduction of the 81 tons of carbon dioxide emissions, or the planting of the 4,481 trees. The third product, also in Shanghai, is a villa. The roof is made of brick red sunshine tile, and the overall effect is fantastic. It is worth noting that the sunshine tile are not only available on the classic black color, but also in brick red to suit different architectural styles. We also have the smaller size of tiles, which I believe is very beneficial if you want to install them in more areas of the roof to achieve more power and a higher visual effect. GOODWE PV building materials are more than just sunshine tiles. We have different products to match the different scenarios, including the zero carbon life, zero carbon sunroom, zero carbon traffic, and zero carbon factory. Zero carbon sunroom is a typical scenario of some Starlux products, which has the different light transmission rates to meet different lighting needs of buildings. The products in the zero carbon traffic scenario is the Polaris, which can be applied on not only to the roof of the factories, but also the PV carport, which is a unique development potential scenario. In conjunction with the PV of a GOODWE series of the devices, it forms a solution for solar-powered EV charge with integrated battery storage. As to the zero carbon factory scenario, there is a product that allows for certain angles of bending of accommodate more complete roofs, which name is the Galaxy. It has a low weight and good waterproofing performance, make it ideal for application on factory roofs. If you are interested in these products from GOODWE, please follow our channel or contact with me. And we will introduce about products in the future. So that's all of my today. Thank you for listening. And our vision is that we want every building in the future to generate power and every person to be a creator of energy so that we can work together for up to a sustainable future. Thank you.
Thanks for Rita's sharing. The concept and application of PV building materials are very interesting. And coming up, we are very delighted to invite Kira, the technical engineer of PV product in TUV North China, to give us the interpretation of PV building materials product test standards IEC 63092. Welcome, Kira.
Hi, this is Kira from TUV North, and today I want to share the Building Integrated Photovoltaic Product Certification and Evaluation. First, I will have a brief introduction about TUV North, and the next we will have three standards sharing of IEC 63092, IEC TS 63126, and the European standard EN 50583. TUV North has been found for more than 150 years, devoting for safety, security, and successful knowledge. We have different scope of service, including information technology, aviation, and nuclear energy, etc. The PV project has been developed globally. We have more than 140 global branches, has issued more than 1,000 certificates, as well as the global market access service. TUV North is a member of National Certification Body, and our colleagues, Mr. Roger Miao and Mr. Shelby Wei, are the members of Committee of Testing Laboratories. We have 5 CBTL in Greater China. And we also have developed customers testing facility scheme like Jinko Solar and China Solar has been developed as CPF3, which is the highest level of PPF. So here comes to the BIPV related standards from various religions, including IS, which is representative for international standard, EN representative for European standard, and CN, which is representative for Chinese standard, also including US standards, etc. And first, we will introduce the IEC 63092-1. IEC 63092-1 specifies building integrated photovoltaic module requirements, where IEC 63092-2 specifies BIPV system requirements. Both parts specify building requirements and the applicable electrotechnical requirements. So for building products, there are 7 requirements, including mechanical resistance and durability, and safety in case of fire, hygiene, health and environment, safety and accessibility in use, protection against noise, energy economy and heat retention, sustainable use of national resources. These 7 requirements are to be introduced for the next for further introduction and for further standards to take. So here we introduce one definition, which is for the application of different categories of products. This is sloping and non-sloping module. The modules can be divided into 4 categories, including a horizontal module, module considered to be sloping, and module considered to be non-sloping, and vertical module. So here comes to the 5 application categories, which can be divided by 2 dimensions, including sloping or non-sloping, and also if the module is accessible within the building. So for category A and category B, they are the sloping PV modules, and as GOODWE introduced before, their products and chattel can be sorted into category A. And for category C and category D, they are vertical PV modules of BIPV products, and it can be considered as curtain walls or the facades. And for category E, it is the externally integrated and not accessible within the building. So for products like window shades can be sorted into this category. So this is a concrete scheme of the different PV products, BIPV products used in the building. This is a scheme from IEA, so we can see like different categories are used as different products within the building. So next we introduce the second definition, which is the optically representative area of the module. This definition is in corresponding with the complete module. So the reason why we introduce this definition is to take convenience for testing and certification. So when the optically representative area of the module meets the requirements, like with the similar optical properties and G value with the complete module, it can be considered as the testing sample. So it brings convenience to the testing and certification. So this is a simple diagram of the optically representative area of the module. As the number 5 definition, it is a square of it's like a sample of optically representative area of the module. So when this part meets the requirements of the optically representative area, the factors can make a sample like this to the laboratory. So we can take the testing and instead of the complete module. So as we have introduced before, there are 7 requirements for the BIPV products, and for each requirement, we have the corresponding standards. So we can see it one by one. So for electrotechnical requirements, the BIPV modules should meet the basic standards like IEC 61215 and IEC 61730. So it is the basic certification of PV modules. For the second one, building-related requirements, the module should have passed the mechanical loads testing. It is also includes in the IEC 61730 standards. And for the third one, mechanical resistance and stability, there are several standards for this clause. So for IEC TS 63126, it is the technical specification of IEC for the PV modules and components operated in higher temperature, which will we will have a specific introduction of these standards. And for the next clauses, like the fire requirements and hygiene and health and environment requirements and safety and accessibility in use and protection against noise and energy economy and heat retention, we have all corresponding standards for these clauses. Here comes to IEC TS 63126, and it is the standard for PV modules, components, and materials for operation and high temperatures. So we have a brief introduction of this standard. This standard is suitable for roof parallel or building integrated rooftop applications in climates with local environmental temperatures that exceed 40 degrees. So we will introduce 2 definitions. One is 98 percentile temperatures. It is the temperature that describes the the PV module working time in the whole year. That the temperature, if the temperature exceeds the 98% of the temperature in the whole year, we can consider that this temperature is the 98th percentile temperature. We have 2 levels of this temperature, and level 1 is between 70 degrees to 80 degrees, and level 2 is between 80 degrees to 90 degrees. The PV modules can be divided into 3 categories, which is in the open bracket as the normal PV modules mounted. And for the next one is a closed roof mounting way, and it can be considered as BIPV products. And for the next one is insulated way of mounting way of PV modules. It can be considered as BIPV. So for BIPV modules, it should be tested in a serious conditions, like higher temperatures, because it has poor ventilation and heat dissipation conditions. So for the diagram in the right position, we can see that the BIPV products are suffered in a very higher temperature. So it is necessary to have serious conditions of testing to test if it can be tolerated in the higher temperature and more serious conditions. So this is the diagram of temperature temperature in the whole world, like in different continents or different places in the planet. So for the open racket mounting way, that we can see the working temperature in this section is almost less than 70 degrees. The highest degree in the highest degree in the area of the highest degree is in Africa continent and the South America continent. And for the BIPV products, the temperatures are higher than before. So as in the Africa continent and the South American continent, the temperatures can exceed 80 degrees or 70 degrees. And for the BIPV products, the temperature suffer the most can be between 80 degrees to 90 degrees. So what tests should we do, and what the conditions can be raised, especially for PV modules like the standards IEC 61215 and IEC 61730. There are several tests should be taken, and the conditions are raised for temperature in level 1. The temperature of each test can be added like 10 degrees or 15 degrees. And for the level 2, the temperature can be placed like 20 degrees or 25 degrees. So the conditions are more serious to demonstrate that the product can suffer in a higher temperature. So it can meet the serious conditions like BIPV modules. We'll have a brief introduction of EN 50583. This standard is used as the European standard. So for the international standards, we previously introduced like 63126. This standard originates from the European standard. So these two standards are considered almost the same, except for the European Construction Product Regulation, CPR 305, 2011. This is especially used in European continent. So this is the only difference between these two standards. And for also in these standards, the BIPV modules are divided into glass panes and not containing glass pane. So for these two categories of BIPV modules, different standards for European standards are used to evaluate different products. So for the CPR 305 we introduced before, we have the different testing test for each clauses requirements. So it's for the European parts, it's almost similar to the 63092. The ST branch of TÜVNOT has the accreditation of CPR 305. So in this seminar, we share several definitions and related standards of BIPV modules. BIPV products and applications are coming into a rapid developing product period, and TÜVNOT will bring a series of services of testing and certification and provide technical support for BIPV manufacturers in stages of product design, performance and safety evaluation, and related global markets access. So if you want more information, please contact us. Thank you for your listening.
Kira, thank you. It is reassuring to hear that Sunshine Tiles has obtained certification from TUV Nord for BIPV product under international standard IEC 63092. And thanks again for both speakers' excellent presentations. Now we are going to have Q&A session. Please feel free to ask any question or share any thoughts with our speakers. But let's first take a look at some questions that are asked during the webinar. Okay, so the first question, what is the difference between the maintenance of Sunshine Tiles and conventional PV modules?
Firstly, I think I should recognize that the BIPV, the Sunshine Tile is the product of the PV building materials. It's building materials, and the PV modules is the photovoltaic products. So the Sunshine roof being integrated into the roof and designed as a building material, so requires the minimum maintenance. But for the PV modules, if they are requested by local regulations and standards for the PV systems.
Thank you, Rita. So the next question is, what services do we provide?
We provide the technology support to the both PV and the construction professionals to help get across the the barriers they might encounter during the application of the multi displaying the product.
Thank you. And here is another question. So what's the difference? Okay. It seems someone wants to communicate with our speakers. You can unmute your microphone, please. Okay, sorry for this. It seems some issue occurred that we can't hear your voice. So let's go on with some other questions. So the next question is, what's the difference between BIPV and GOODWE's PV Building Materials?
The BIPV, the full name is the Building Integrated Photovoltaics. It's a technology of the photovoltaics materials. But the PV building materials that can replace the conventional tiles and can replace the in part of the building envelope, such as the roof and the sun slides or facades, In term building applied photovoltaics, for the BIPV, its full name is the building attached photovoltaic. It used to refer to photovoltaics that are to retrofit the integrated into the building after construction after the construction is complete. So most building integrated installation are accurately BIPV. Some manufacturers and builders different new construction the BIPV and the BIPV. Our PV building materials is a series of the PV products result in the successful adaptation of BIPV technologies. The products and these products are designed to be the building materials that are not only safe and durable, but also incorporated PV technology to the general green power. I think this.
Thanks for Rita's answer. And there is another question. What are the major factors considered when selecting the roofing materials?
And firstly, I think the safety always be the first consideration for the roofing materials, such as the fire safety and wind resistant and waterproofing, followed by long lifetime acoustics and also be eco-friendly. I think that's the most important for the consideration with the roofing materials.
Okay, so can you leave the contact details for us to get in touch?
At the end of the webinar, we will leave our contact details on the screen.
Okay. So does anyone has any questions? Okay, here comes another one. Is there any successful cases or project overseas?
We are working with several building materials distributors and developers in some of the showroom, such as the Australia and Germany, and you will be able to see our products live in the Melbourne soon.
Yeah, thank you. So the next one is, which is more efficient, PV modules or BIPV?
As this question, there are so many different types of the BIPV products. It's really not this or that question. In terms of sunshine series products, efficiency of sunshine and conventional modules are comparable. Feel free to contact us if you wish to learn more.
Well, thank you. Okay, I think, sorry, just wait me for a minute. I think here is a question for Kira. Does BIPV need local building material certification in Australia and New Zealand? Kira, can you help us?
So different countries have different requirements and standards of building products, and for certification in Australia and New Zealand, first the manufacturer should get the CEC certification, and then we can do the BIPV products. So first, so this is the first step. Yeah, and for the region in Australia and New Zealand, we can do what there's regional standards. Yeah.
Okay, thank you, Kira. Well, seems like that's all the questions. We have come to the end of today's webinar. Thanks for your participation. And if you are interested in PV building materials, please contact us through the contact information on the screen. Hope to see you again soon.